All right, finally it says I am live. It says that the stream is healthy. I got the green light. All I need are students, right? So I appreciate you guys being patient with my technology. You'd think it would be the same thing every time that I just turn it on, and really what it is this laptop that I use to live stream from. My kids and family use it, and so like every time I turn it back on, the settings get reset. Yeah. So I'm gonna wait like about 30 seconds just for you guys to get logged on. Again, you don't have to watch it live. You can watch it after it's already streamed, and then you can take notes and then get credit that way. All right, cool. You guys are back. Nice. Thank you. Let's get right into it. So we're looking at the first problem. A lot of you guys have done it already. For those of you who didn't feel great about it, we'll go over it real quick. I'm going to kind of speed through this. Again, if you need to slow it down, you can always, when I finish with this video, you can pause it and rewind and do what you need to do. But I want to get through it because I know you guys have been here waiting for a while, and it's getting late. And a lot of you guys have already done this. You're just tuning in for the extra credit. So respect to you guys who are putting in that extra effort for the extra credit. All right. So number one, what is the area of the composite figure shown? Now, whenever we're doing a composite figures problem, we have to break the figures up into shapes, right? So from there, I can see there's a square and a triangle. Now, it's easy to tell the square, the formula for the square is area equals base times height. You guys are pros at that by now, which means area equals 8 times 8 equals 64. So the area of this square would be 64 centimeters square. And then now we have to find the area of that triangle. Now the tricky part about that triangle is how do we know which one is the base and which one is the height? So the formula for this is area equals 1/2 base times height, or as I've explained to some of you guys, it's area equals base times height divided by 2. Whichever works easiest for you, use that one. Don't confuse yourself. Now, how do we know which are the base or which are the height? They put this 13 here to trick you because they're assuming that you're not going to understand what the base and the height are. We always know the base and the height because they're connected by the right angle, right? This right angle connects the base, right? This is our base right here, and then our height on the other side. Now, here's the only problem. They gave us the base, so we know that the base is going to be 5 times. How do we know this height right here? Well, a lot of you guys automatically said 4, but 4 centimeters is only from this part of the height to that part of the height. We need to include the rest of this height right here, which is the opposite side of this square. We know that squares have 4 congruent sides, so if this side is 8, this side is also 8 centimeters. So 8 plus 4 is 12. So we have 5 times 12 divided by 2. 5 times 12 is 60 divided by 2 equals 30. So the area of this of that triangle there equals 30 centimeters. The area of the square was 64 centimeters. We'll add the 2 of those, 94 centimeters square. All right, move on to the second one. Second one's pretty simple. Again, it wants to know how many square feet of carpet will Mr. Davis need to cover the floor shown. So we can break this into shapes, right? We have two rectangles. You can break it up into any rectangle you like. I'm just going to break it up into these two rectangles. So I have a big rectangle here, a little rectangle there. I'll take the dimensions of this first rectangle. We know that the formula is area equals base times height. The height, or we can't tell the base because this entire base is 15. A lot of you guys make mistakes by going through it quickly and just seeing the 15. You have to realize that that 15 measures the span of both of these figures. So I have to figure out what's the difference between this and the entire thing. Well, the entire thing is 15. I know from here to here is 5. I'll find the difference, which is 10. It's going to give me my base. So 10 times the height, which is 20. So again, this here is 10 feet. This here is 20 feet. 10 times 20 equals 200. So we know that the area there is 200. Then I know for here, area equals base times height. Well, the base is 5 feet. The height is 6. 5 times 6 equals 30, right? So 30. Again, you should be showing your work. Number 3. Number 3 is a pretty... It's an easy problem. There's just a lot to it. So I'm not going to go through each one of those answer choices, but I'm going to show you how I would have broken the shapes up. Now, when we're talking about the shapes that you're going to be finding area for, you're going to be finding the area for rectangles, triangles, parallelograms, trapezoids, and circles. Area equals pi r squared. Okay, so every time I'm breaking these shapes down, I'm trying to figure out which shapes are there. So here I can look, I can make out that rectangle pretty well, or actually it's a square because we can see the dimensions here are 18 by 18, right? So that's an 18 by 18 square. And then I can see here this is a trapezoid. So I'm going to look out for the formula for the area of a trapezoid. Remember, it's 1/2 times base 1 plus base 2 times height. Now, the way I'm going to do this is I have to figure out what my base 1 is here. It says my base 1 here is 6. So base 1 is 6 plus base 2, which is this entire space right here. Well, how do we know what this entire space of the trapezoid is here? We're going to have to do a little figuring out. So we know this entire space from here to here is 18. Well, from here to here is 6 and 6, so we know that's 12. So base 2 is going to be 12. So our trapezoid here is 1/2. Area equals 1/2 times 6 plus 12 times the height. It shows us here that the height is 4. Oops, it's off screen, sorry. So we're just going to add base 1 plus base 2, 6 plus 12. 1/2. 6 plus 12 is 18 times 4. Well, 18 times 4 would be 72 times 1/2. 1/2 times 72 equals 36. So I know that the area for that little trapezoid would be 36. I'm not going to finish the rest of that one. I just wanted you to see how to find the area of the trapezoid there. The next one's pretty straightforward. You have a rectangle and a square to find the area of, right? This question asks which composite figure has an area of 372. So you have to go through each one of them to find out which one has an area of 372 square meters. The next one, we have to identify the figures. So the figures here are, there's a parallelogram, a rectangle, and then another parallelogram. I can tell that these two parallelograms are congruent, right? The formula for the area of a parallelogram is area equals base times height. And then if I look here at the parallelogram, the base is 18. And we always show that the dotted line tells us the height. The height is 6. I would multiply that. It would give me my area for the parallelogram. And then for the rectangle would be 18 times 6, base times height. Pretty straightforward. This parallelogram is congruent, so it would be the same area that we would find for this one. I'm going to move on to the final answer choice here. Again, we're breaking it down into shapes first. So I have an 18 by 18 square, and then I have a trapezoid, right? So this trapezoid, it doesn't show us the height, but I can see from here to here is 4. So I know that's 4. So that's the height of my trapezoid. So my formula for finding the area of this trapezoid, area equals 1/2 times base 1 plus base 2 times height. So then we know base 1, this is base 1 here, which is 6, plus base 2, which is this little measurement right here, which is congruent to the other side, which is 18. 6 plus 18 times the height, which was 4, times 1/2. You can simplify that. I'm going to move on. So you have to go through each one of those to figure out which one has an area of 372 square meters. Here, Nick is finding the area of the composite figure shown. So first of all, let's break it down into shapes, right? I have one square and one rectangle. And then from there, we're going to read to see which one of these shows how to find the correct answer. So A says to find the sum of the area of a square with the side length of 8 feet and the area of a rectangle with a length of 18 feet and a width of 15 feet. So A sounds good because it says there's a square that's 8 by 8, and then there's a rectangle which is 15 by 18, which we have here. B, find the sum of the area of a rectangle with the length of 15 feet and a width of 4 feet. So that's kind of suspect. And then the area of a rectangle with the length of 23 feet and a width of 8 feet. And the area of a rectangle with the length of 15 feet and a width of 6 feet. This one seems a little suspect. So B might be the one that's not. Let's come back to it. C, find the sum of the area of a rectangle with the length of 8 feet and a width of 4 feet. Subtract that sum from the area of a rectangle with the length of 18 feet. You know what? Don't worry about this problem. I don't want to spend a lot of time of it. We could go through it. Ultimately, it's a bad question. I'm not a big fan of it. Don't worry about number 4. We're going to move on from there. Number 5, the floor of the stage at a school is shown below. The whole floor of the stage must be covered with artificial grass for a play. The dashed lines complete the smallest rectangle into which this entire stage could fit. Which equation has to find the area of the stage floor by using subtraction? Now, first of all, we have to understand what the dimensions of the entire area, meaning the the height and the base of this the large rectangle, right? We're looking at the big rectangle, not the stage by itself, and not the empty space. If we're looking at the entire space that the stage can fit in, I can see it's 20 by 18 feet, 10 feet, and 18 feet. If I add up these three, 18, 18 and 10, 18 plus 18 is 36, 36 plus 10 is 46. So what they're saying is this entire base is 46 feet. So again, that entire base here is 46 feet. So if we look at all of these problems, one thing that they have in common is they all start out with an area and then they're subtracting, which looks like should be this space right here. So let's see. The area of the big rectangle here would be 46 by 20. Right? We'll say 46 by 20. If I multiply 46 by 20, I get 920. So the entire area of all of this, even these empty spaces, would be 920. So I know that we're going to be subtracting these two empty spaces from the 920. I can get rid of A and B, which leaves us with the next part. Next, we have to find out what the area of these little rectangles are here. The little rectangles. Well, I know these are 18 by 10. This is 18 right here. This measurement here is 10. So that's an 18 by 10 rectangle. So I know this is 180. If I multiply 18 by 10, I get 180. Again here, this is 180. So, which leaves us with 920 minus 180, which is this area, plus 180, which is this area, equals 560 feet. D is our answer. 6, what is the area of the composite figure? We always have to break down the composite figure into smaller shapes. I'm going to put a little dotted line here to show you where the rectangle breaks into a trapezoid. So we have rectangle, trapezoid. I can see the dimensions. For this rectangle here, area equals base times height. The base would be 11. The height would be 18. Right? 11 times 18, let's see, 18 times 10 would be 80. Plus another 18 would be 198. So that should be 198 meters squared. And then here for this trapezoid, we have area equals 1/2 base 1 plus base 2 times the height. So we can see that base 1 is 12. So we'll say 12 plus. Base 2 here is 18 because you see this is a rectangle here. And these two sides of the rectangle are congruent, plus 18 times the height. We're going to have to find the height by finding the difference. So this entire space distance here is 19. Well, it cuts it off here, and we know this was 11, this was 11, so we'll take the difference between 19 and 11, which would be 8. That's our height, times 1/2. 12 plus 18 would be 30 times 8 times 1/2. 1/2 of 30 is 15. Or let's do 30 times 8 would be 240. 240 times 1/2. 1/2 of 240. The area would be 126. So the area of that trapezoid should be 126. If I add 126 and 198, which one of those? 198 plus 126, 4. I made a mistake somewhere here. Let's see, 18 times 11. 12 plus 18 is 30. 19 minus 11 is 8. So 1/2 times. I'm just finding my mistake. I made a mistake somewhere here, and I'm seeing what I did. 1/2 times base 1, 12 plus. I put 18 instead of 8. Or let's see. No, it was 18. That's the height. 19 minus 11 is 8. 30 times 8 is 240. Oh, this was 126. So that should have been 120. 8. It should have been B, 318. So I made a mistake here, and I caught my mistake. This was 120, right? Because half of 240, if I multiply 1/2 times 240, then I get 120, not 126. I don't know why I wrote 126. I think I misread my own handwriting. So 120 plus 198 would be 318. All right, we've got like 2 more and then we're done. All right, here comes the circles. Marta did the calculations below to find the area of a composite figure. She used 3.14 for pi. And then it shows the work that she did. And it wants to know which composite figure has an area that can be found using Marta's calculation. So let's see what she did. So she did a couple things. She did this right here, 10 times 12, which if I'm thinking of any of the objects that we've been finding the area for, whenever we multiply 2 numbers, it's usually base times height, and that's either going to be a rectangle or a parallelogram. So keep that in mind, right? So I'm thinking that this is maybe a rectangle. If I look at all the answer choices here, there's nothing but rectangles there. So I feel like that's probably a rectangle. Then the next formula is 1/4 times pi times 5 squared. Now, whenever we're finding the area and we have pi r squared, that's usually the area of a circle. Again, whenever we have pi r squared, that's usually the area of a circle. And if they're multiplying it by 1/4, I'm going to zoom in a little bit more. Zoom in a little bit more. All right, let me just backtrack a little bit more. So again, we're trying to figure out which one of these shapes in the answer choices represent the work that she did. So first, we can tell that she found the area of a rectangle. One, because there's rectangles on all these, and we know that the formula for the area of a rectangle is base times height. So this would be base times height, 10 times 12. Then if we're looking at the next piece of work that she did 1/4 times pi times 5 squared. Well, we know that the formula for the area of a circle is pi r squared. So we're assuming that whatever circle that she's dealing with here, it has a radius of 5, right? Let's look at the circles that we have in our answer choices. Well, if we're looking at A, the circle has a diameter of 12. So we know that the radius is half the diameter. So if this diameter is 12, this radius should be what? Radius should be 6. This here shows pi r squared, or pi times radius squared, pi times 5 squared. This can't be it because this should be pi times 6 squared. So we're going to get rid of A. A doesn't work. Let's look at B. B again has a radius of 12. which means, I'm sorry, it has a diameter of 12, which means the radius would be 6. We can get rid of B because we know that we need a radius of 5, which leaves us with the last two answer choices. Now, this circle here has a diameter which is 10, which means our radius is going to be 5. So this is a potential choice. And then lastly, our last answer choice has a diameter of 10 again, which means this radius is going to be 5. So those last two answer choices are two possible choices that we could go with. Now, we know based on this formula, 1/4 times pi r squared, that we have to have a circle that has a radius of 5. And the fact that they're multiplying it by 1/4 tells us that it's a quarter circle, right? Because 1/4 is a quarter. So this here is a quarter circle. And then the one next to it is, they have pi r squared again. And we know that this radius, this r, is 5, which was the same as before, which means that both of these circles have a radius of 5, which is good because they do. But this is saying a half circle. So she has a quarter and a half. So a rectangle, a quarter, and a half. Let's look to see which one has that. It's going to be either C or D. So rectangle, yes. A quarter, yes. And a half, yes. So the answer here is C. Again, so this would be 10 times 12 for the rectangle. This is the quarter circle, which would be 1/4 times pi times 5 squared. And this half one would be 1/2 times pi times 5 squared. All right, last one but not least. An artist is painting a mural on the side of a building. As the background for the mural, she paints a hexagon represented below. What is the area in square feet of the hexagon the artist painted? So we have to break this down into shapes again. So I can see that there is a triangle, another triangle that's congruent to that triangle, and then we can see that there is a big rectangle in the middle. So we're essentially going to have to find the area of a rectangle, and since these triangles are congruent, we're going to find the area for one of the triangles and just double it. Now, first of all, if we look at the measurements of this rectangle, we can see that the base is 12. So we're looking at the rectangle. Area equals base times height. Area equals 12. And then the height of this rectangle we're looking at, this is 5 feet. We know that this triangle is 10 feet. If from here to here is 5, we know from here to here is 10, right? Or we can look at the drawing. I just did an unnecessary step. We look at the drawing, it labels that as 10 feet. So that's 12 by 10. 12 times 10 equals 120. So we know that the area of that rectangle is 120 feet squared. Now let's find the area of the triangle. So I can see this triangle has a height of 4 feet, right? So first of all, let's write down the formula for the area of a triangle. So the area of a triangle equals base times height divided by 2. Some of you guys like to see 1/2 times base times height. Now, I can see that the base of this triangle is 10 because from here to here is 10. So that's 10 times the height of this triangle, which I tell you the way that you know the base and the height is from the right angle. You see this right angle here? that kind of tips us off. This little right angle here, that little box, tips us off, and that tells us that connects the base and the height. So I know that my base is 10, my height is 4. 10 times 4 divided by 2. Well, 10 times 4 equals 40 divided by 2 equals 20. So I know that the area of one of those is 20 feet squared. So the area of these are 20 feet squared. So there's 2 of these triangles. Each one of these triangles is 20 feet squared because we did base times height divided by 2. 10 times 4 was 40 divided by 2 is 20. So we know this is 20, this is 20, this was 120. We need to find the area of the entire hexagon. 20 plus 20 is 40. 40 plus 120 is 160. So it should have been 160 feet square. So I realized that I kind of raced through that, guys. The technical difficulties that I had earlier kind of set me back, and so I just wanted to get this done and over with. We actually got this done in 30 minutes, which is record time for some of these videos. If you didn't get to take down all the notes that you needed, or you didn't understand something, try and rewind the video as soon as I stop it and publish it. Rewind it, slow it down, take whatever notes you need to. I'm going to allow you to use this on the test tomorrow as a resource. I expect you to see it out on your table. And like I said, if you did this and you did my notes, not the fact that you did the review, but you did my notes, and I'm going to know them by seeing them, right? And let's say the password here is going to be quick drawing. So the password for today's video, and that's one of the ways I'm going to know, I want you to write on your paper the word quick drawing. If you took notes and you did the review, really big on top of your paper, I want you to write quick drawing. Don't tell anybody, because you don't want to give anybody any free work who didn't do this work, right? So I know the answers that I gave you. I know the problems that I skipped over. And so I'm going to be looking specifically to see that you had the exact problems that I did and that you don't have the ones that I skipped over. And for those students who followed along and who took notes on what I did, again, I'm going to give you guys 25 extra points, which will replace like a do now grade, or a couple of other of the assignments that we've done in class have been 25 points. And I'll make sure those are knowledge and thinking points, because those are the ones that weigh the most. Again, guys, make sure to use this on your test tomorrow. I feel like this is probably one of the better units that we've had. You guys have been able to understand and grasp this. Take your time, draw the pictures, write the formulas out for each one of the shapes that are there, and you're going to do awesome. Other than that, I'm about to go downstairs, hang out with my kids, and eat dinner. Enjoy the time with your family, and I'll see you tomorrow. Peace.